So yeah, let's start. So today I will be talking about my experience of migrating a large project from Mockito 1.X to Mockito 2.X. My name is Hazem Saleh. I'm working as a software architect in Viacom, New York. So the first part of this presentation, I will show you the challenges of Mockito 1.X and why do we have problems in Mockito 1.X and how could we solve these problems in the old ways. The second part, I will show you the advantages of Mockito 2.X and how can we really write a clean unit tests in Mockito 2.X. We'll also show you the tips and the tricks which can allow us to successfully and smoothly migrate from Mockito 1.X to Mockito 2.X. I will show you demos, and I will also show you some techniques which can allow us to write 100% clean unit tests in Android. Finally, I will be talking about Kotlin, and I will show you a demo about how we can use all of that in Kotlin. So, what are the challenges of Mockito 1.X? One of the biggest problems of Mockito 1.X is it didn't allow us to mock final classes or final methods. If we try to mock final classes or final methods, we usually see this exception in the log. Cannot mock or spy this final class or this final method as we see here. And also if we have some static methods that needs to be unit tested, unfortunately Mockito 1.X doesn't allow us to do anything about that. So we had to lean on a third-party solution like PowerMock, which is really a set of APIs that allow us to do this kind of mocking. Unfortunately, these APIs are really different from Mockito 1.X APIs, and I will show you a demo. Adding to that problem, using PowerMockito was not really a perfect solution because PowerMockito is really slowing down the unit tests if we have hundreds or thousands of unit tests in our code base. So we really needed to also overcome this technical debt. So let me show you Mockito 1.X challenges in action. This project again can be reached in GitHub. Feel free to download it at any time. So this is a demo Android app which I have in GitHub. The idea of this project was to show the community how we can develop MVP applications in Android using Dagger, Retrofit, and RX Android. So it has two main use cases. The first use case here is to show the projects that are owned by Google. So we can click any project here and see the details of the project. The other use case is to show the weather information for any certain place here. So you enter your name, you enter the city name, and then you click go and you get the weather information. So the idea here is to show how we can do an end-to-end integration between the user interface code and the backend services that we need to talk with. So if we open here the code, let's open one of the use cases here. So we start here from the weather fragment. How can we get information for the weather? So we have here a weather fragment. This weather fragment is dependent on a presenter. If you are familiar with MVP pattern, we have a presenter which is talking with a model that finally returns the result to the presenter, and finally the presenter is talking to the view to show the information. So here we have a weather presenter. This weather presenter is getting the weather information whenever we click the show information button. If we get into the details of this method in the presenter, we'll find it call another get weather information method in an interactor. What is the idea of interactor? Again, this is like a use case. So in clean architecture, you have usually a use case which is containing the real business logic that you need to do, and this use case usually is talking with a repository object in order to fetch the data, and inside your use case you can get the data and sending it to the presenter in order to do whatever massaging and finally sending it to the view. So here, this is what exactly happened in the weather presenter. The weather presenter here, we get the weather information, we send the user name and the city text, and once we receive the object here, we receive something called weather summary information. Here, what this presenter is doing some sort of transformation. So it gets the temperature here and it converts it from Celsius to from Fahrenheit to Celsius, because the application is showing the degree in Celsius, and then it formats the result using some weather data formatter and returns the result, the formatted result, to the main view. This is actually the core of that we really would like to unit test. So here, if we get to the get weather information, what we have here is a use case which is talking with a repository object that uses retrofit to retrieve the weather information. This is the end-to-end flow. So let me show you how we can unit test something like this. As you see here, we have a weather presenter which is dependent on a weather interactor, and it receives the weather summary information as a result, and it takes this weather summary information and talk with some weather degree converter to convert the degree from Celsius to from Fahrenheit to Celsius, and there is another weather data formatter that takes this weather summary information and format it in a certain way, and finally it go and displays this information in the main view. So in order to test unit test something like this in Mockito 1, we really had to do this. So weather interactor and weather view, they are really non-final classes with non-final methods, so no problem. We just use the @mock annotation. But what about mocking the weather data formatter and the weather degree converter, which receive the weather summary information to be displayed in the view? If we see here the weather data formatter, we will find it is just a final class with a final method. And if we see the weather data converter, we'll find it has a static method. So unfortunately, we had to lean on something like PowerMock here. So we had to annotate our class with run with PowerMock runner, and prepare these classes to be unit tested. And here we are using totally different mock APIs. So in order to mock the weather data formatter, we use Mockito mock, and in order to mock the the weather degree converter, we use something like mock static. So here we see the complexity. Here we have really different APIs that we used in order to just unit test a single and a simple API. So now we mock the weather interactor, weather view, weather summary information, weather data converter, and then we invoke the method under test, and finally we assert here. Even in the assertion here, we adding to the verify of the Mockito 1.X, we use another verify method for PowerMockito called the verify static in order to assert the codes. This is not really a clean unit test, as you see here. It is like very complex. We have many frameworks in order to really test a very simple scenario. So what is the solution? So the solution to this problem is to start using Mockito 2.X. So Mockito 2.X has great advantages. It allows us to mock final methods, final classes. It supports Java 8. It also migrates from CGLib to ByteBuddy. ByteBuddy is a young code generation library. It overcomes many of the problems which CJLib has, and also the open community of CJLib, they said, like the project is really now under maintenance and we do not add more features to it. So it was really an important decision by Mockito 2.X team. The question here is, if you really have a big project with tons of unit tests and you would like to migrate it from Mockito 1.X to Mockito 2.X, is it really an easy job? Unfortunately, no, it is not an easy job. Especially if you have another dependency on PowerMock. So if you have another dependency on PowerMock, the complexity will really be increased or actually doubled, because Mockito 2.X is not compatible with PowerMock. This is the other dimension of complexity. So this is really a true story. Like when I tried to migrate a very big project, with tons of unit tests, actually in thousands of unit tests, from Mockito 1.X to Mockito 2.X. Once I changed the Mockito version in the build.gradle file, I find many exceptions. More than 50% of the unit tests were failing due to many issues. Null pointer exceptions, compilation errors, no class definition exceptions, unexpected thrown exceptions, and in order to overcome these challenges, I documented all the steps which allowed me to successfully migrate from Mockito 1 to Mockito 2. The first step here is to use the right matchers. One of the decisions which were taken by Mockito 2 team is to change the org.mockito.matchers package to org.mockito.argument.matchers. So this is very quick one and very easy to do. So once you did this, you are done from this step. Don't use the old packaging way. The second tip is really deep, and it can cause a lot of problems in your tests. It was also a decision taken by Mockito team. Any string does not match null anymore. So in string, in Mockito 1.X, it was matching a string value, and if this string value is null, it was really working fine. Mockito 2.X team decided that any string should not match null anymore. And to really solve this problem, we have to really review the old failing unit test. If this old failing unit test was really intended to assert a null value, what we can do is simply replacing the in string with a null value, and it is all what you need to do. The problem here happens when you review your unit test and the intention of this old unit test was not really to assert null, and because of that, it really failed when we migrate to Mockito 2.X. So what is the solution to this problem? The solution to this problem is to rewrite the unit test in order to make sure that you are asserting a non-null value. So let me give you an example. Assume that we have this structure. We have a message handler, and this message handler is having two dependencies: message processor and message formatter. So in the constructor here, as you see, we just inject the dependencies, the message processor and the message formatter, and we have some handle method. This handle method is taking a string, and it processes the string using the message processor.process, and the output of this is taken to the message formatter.format, and finally the result is being returned. How can we unit test something like this? Simply, we will mock the dependencies like what we are doing. We will mock message processor, we will mock message formatter, and in the methods that we are trying to unit test, we will call the method under test, and we will verify that the process message is called in the process method of the message processor is called, and the format method of the message formatter is called, and we will put here in string. What is the problem of this unit test? So this unit test will really work fine in Mockito 1.X. In Mockito 2.X, this will not work, because any string here will be evaluated to a null value. This can happen like many times in the old unit tests that you are trying to migrate. If you look here to this unit test, you will find that really instring here didn't really intended to match null. It really intended to match a real value. So how can we fix this problem? To fix this problem, we have to properly complete mocking the dependencies. So here, in the given part of the unit test, we mock the process method. So whenever the process method is called, we just return some processed message, and we call the handle method of the message handler, and finally we just assert the values. We assert that the process message is having the message that we really intended to assert, and finally the format method is calling any string or is calling or is having the processed message which we specified here. So if we look deeply into this, we will figure out that Mockito 2.X revealed some of the incomplete unit tests which we had in Mockito 1.X, and this is really an important step that we had to do in our project, to review all of these old unit tests and to fix all of them, to make sure that once we migrate to Mockito 2.X, we'll also have clean and meaningful unit tests. Any questions? The third tip here is any int. Any int in Mockito 1.X was very tolerant. It was, like it could match long letters. It could match 0L, 10L, or whatever long values. Now this doesn't work anymore, so it is very easy tip. If you have a case like this, just replace any int with any long. The next step is very important tip if you use white box. Do you use white box before?
Yeah.
Excellent.
Too many times.
Okay. So Mockito 2.X does not have white box anymore. So if your old test is dependent on if your old unit test is dependent on white box, it is not supported anymore because Mockito 2.X team decided to remove this class. In my opinion, this was a really right decision. Why it is a really right decision? Because white box at the first place promotes the idea of writing a bad unit test. Why? Because as you know, the developers is using white box to change the internal state of the object that is under test in order to make the test pass, which is really not a good practice. So how to solve this problem? There are two ways. One way which I really don't recommend, and one way which I recommend. The way which I don't recommend is to use PowerMock white box. It would be like easy option, but I really don't recommend to go this way. You may lean on this way if you have a very tight time and you would like to just make the migration now, but this is not really the right way. The right way is to refactor, to see the failing test in the beginning and to ask yourself a question: why do I use white box in the beginning? And one of the ways which allowed us to completely get rid of white box is to refactor the code which is under test, to make sure that all of the dependencies of the object under test are being passed as part of the constructor. So by doing this way, we really hadn't to use white box anymore. Tip number 5 is just a quick API change. So get argument at is removed now from Mockito 2.X. So just use get argument with the first parameter here. So the second parameter is not considered in Mockito 2. Let's start with tip 6, which is talking about the fancy stuff of PowerMock with Mockito 2. So if you try to upgrade, so you try to upgrade to Mockito 2 and you have PowerMock in your code base, when you try to run the unit tests, you may find this exception, no class definition found, and some proxy method interceptor exception as you see here. So if you see this error, usually, most probably, you used the wrong extension of PowerMock Mockito. So what you need to do here is to change this extension from the old value to the new value. So in the Mockito 2, the new extension is called PowerMock API Mockito 2. The other problem, the second problem which you may have also in this integration is exceptions like this, illegal access exceptions. Try to access some method in PowerMock and some exception like this. Actually, when you see something like this, you should know that the version that you are using with PowerMock is incompatible totally with Mockito 2. So how can you solve this problem? You have to do try and error. This is what I did. So for example, I tried PowerMock 165, I tried PowerMock 170 RC2 with Mockito 2.7.1, and they really didn't work. And in order to solve this problem, I had to upgrade to Mockito 170 RC4. The other fancy thing here is that dependencies between PowerMock and Mockito are not really documented anywhere. So this is really a try and error. So my next step here, because we really had big problems with PowerMock, is to move away from PowerMock. And I have a tip that I will show you how you can get rid totally of PowerMock in your code. There is something called wrapper proxy pattern, which I will explain. The last step here is whenever you have this migration tip, whenever you have this migration chance, always try to take a chance to review the project all unit tests, fix the flag unit tests, and either remove the ignored unit tests or fix them. Take this a chance to clean up the unit test code base that you have. So let me show you what happened when we migrated to Mockito 2.X. Let me show you the complex example which we had in the beginning. Again, like I said, this can be reached here in GitHub. Feel free to take it. So this is the weather presenter test which we had, the complex weather presenter test which we had. Now, as we see here, the weather data formatter, we could use the @mock annotation. So the weather data formatter has a final class, has a final method, and we could simply in the given part, in the assertion, in the mocking part, we could simply say whenever the format method of the data formatter is called, then return some certain output, and finally we could assert it very simple like any other class. Take care, because this feature is not supported by default in Mockito 2.X. So in order to activate it, you need to create the following directory called the resources under test, and inside resources you create Mockito extensions directory, and then create a file called org.mockito.plugins.mockmaker, and finally here don't forget to use this word mock maker inline. So if you do that, you will be able to mock final methods and final classes. And it works fine, as you see. So what about static methods? Mockito 2.X does not solve the problem of mocking static methods. So what should we do? What should we do in order to fix this problem? So in order to really fix this problem, I recommend you to lean on some design pattern which can allow you to totally get rid of PowerMock. So one of the patterns which we use is called the wrapper proxy pattern. So This pattern is simply for every class that has static methods. We create a proxy class which is equivalent to it with the non-static methods to be unit tested. And to remove all of the old code references to this method, to this class with the static methods, and just use the new proxy class. So let me show you here the example. So here, we had a wizard degree converter, you know, the I don't know why it is hanging. Yes, can you see it? Okay, so here we have the wizard degree converter, which is having a static method. So all of the older references to this class should be removed, and we create here a proxy class. It has the same methods that we have here in this class, but it is non-static. So what is the value of this? Why should we create a class with a static method? Here, this step is valid if you have a third-party library that has a static methods and you really lean on this third-party library. So in this case, create a class for every class that has a static methods and remove all the references to this old class and just use this proxy class for all of the old dependencies. So let me show you the test here. So inside the test, in the constructor here, as we see, we could simply inject the proxy class to the wizard presenter enable with no need to directly accessing the class with the static method. So by applying this technique, we could simply mock the wizard degree converter proxy using the @mock annotation and dealing with it as if we are dealing with a regular class by using this rabbit proxy pattern. What about Kotlin? Do we use Kotlin? Excellent. So for Kotlin, Mockito, again, Mockito works fine with Kotlin, you know, and but really the syntax is not optimal. So a small tip here in order to use Mockito with Kotlin is to use a library called Mockito Kotlin. Mockito Kotlin is really a wrapper over Mockito, which allows us to have expressive syntax for writing expressive unit tests in Kotlin. So here, this is the syntax of Mockito Kotlin as we see here. It allows us to have descriptive method names. So here in the method name, we can use really an English sentence with the spaces. I will show you now in the demo. And in the same time, it allows us to have inline mocking, which means we can mock the class inline, we can mock the methods of the class inline. So here I'm mocking a class called my class, and whenever get text is called, I return this text. There is no need to mock the class inside the given part of the unit test method. Adding to this, we use some library called Clont. Clont is a fluent assertion library written specifically for Kotlin, which allowed us to write the asserts in this way. So instead of saying assert equal hello world and the result, you can say result should equal hello world, which is really very expressive. So let me show you the demo here. So these are the unit tests written in Kotlin. As you see here, every function, the function name could be represented as a sentence. So here I can say request a project list should return some repo list. So request a project list when username is empty should return some error and so on. And in the same time here we could do inline mocking. So here in the project interactor, here we mocked the project interactor. So whenever the get project list is called with some valid username, we return some success observable. If it is called with an empty value, we return some required username error observable, and so on. So if you see here, it is really neat. The unit test size is getting smaller with Kotlin, and it is very more descriptive. So this is all about. So Mockito 1.X code had some challenges, such as the inability to mock final classes, final methods. Mockito 2.X solved many of these challenges in Mockito 1.X, so it really worth the migration effort. Applying these steps mentioned in the presentation could facilitate this migration from Mockito 1.X to Mockito 2.X. You can get rid of PowerMock if you use the wrapper proxy pattern, which I illustrated here. Do you have any questions? Okay, thank you. Thanks.